Assalamu alaikum wa rahmatullahi wa barakatuh, friends. Welcome back to my channel. In this session we will discuss this IR2153, this IC. We will see its function, how this IC works in the circuit, and how we can test it. I received too many questions from my viewers to explain this IR2153 IC. Basically it is a self-oscillating half-bridge driver. What is half-bridge driver? In any power supply, when the DC rail voltage, these are the DC voltage, are splitted into two portions, it is positive, it is negative. For example, in case of 220 volt operated power supply, we will have 310 volt here. This is return line, 155 here, 155 on this capacitor. Then the positive line is supplied to this MOSFET and source is connected to this winding. When this MOSFET will switch, positive voltage from this capacitor will flow in this winding from this series coupling capacitor. It will complete its path. At that time this MOSFET will turn off. This will off, this will on. Now the current from positive source to this side. But when the cycle will change like here, at that time this MOSFET will turn off. At that time the current polarity will reverse, because this time the current from this side. So bidirectional magnetic field will created in the winding. So this is half bridge circuit. For that purpose this half bridge driver is used. It is IR2153. It is adjustable frequency oscillator. So this IC can drive directly to the MOSFETs. Offset voltage 600 volt, duty cycle 50%, clamping voltage 15.6 volt. So you can say the maximum supply voltage we can apply 15.6 volt, that is VCC voltage. It will provide 1.2 microsecond dead time between both channels. If we see its timing diagram, when the supply voltage will reach at its required level, timing capacitor and timing resistor will start, and this is the sawtooth pulse at pin number 3 of this IC. When it will start, low side and high side driver will switch, and at each changing cycle, rising and falling edge, it will produce low drive and high drive, and between low and high drive there is a time gap. We can see low drive is ending here. After that, after a specific time, the high drive will start. That is called dead time, the off time between two channels. When high drive will off, after that time, that is dead time, the low drive will start, so that the crosstalk between both channels, it will be minimized. Here is its practical circuit, IR2153S and D, two different models. When we are using IR2153S, at that time a bootstrap diode is used between VCC pin and the bootstrap pin. And 2153, no need to use bootstrap, external bootstrap diode. It will provide internal voltage to the bootstrap pin. That is supply for output driving stage. Here is its timing capacitor and timing resistor combination. I will attach the link of this data sheet in the video description. You can check it. Here is RT frequency. How much frequency we need? There are capacitor values. Locate your required frequency. For example, 100 kilohertz. At 100 kilohertz we can use this capacitor, that is 10 nanofarad. When we will use 10 nanofarad, the resistor value will here. If we will use 4.7 nanofarad, the resistor value will increase. If you will use the next higher value 2.2 nano, the resistor will increase. If we will reduce the capacitor size, at that time we will increase the resistor size. Resistor and capacitor combination will assign the frequency, and we can calculate frequency for this IC. F oscillator, F is equal to 1.4533 RTCT. Using this equation we can determine the switching frequency for this IC. Here are different parameters: supply voltage, VCC voltage, under voltage lockout at 9 volts, falling VCC under voltage at 8 volts. When we are using this IC, no need to use VCC winding, because when VCC winding is used, when we will increase the load, the VCC voltage will increase. For Micropower startup, VCC supply current 75 microampere. What is VCC startup current? When we connect to DC rail, to calculate this resistor, this value will be used. Supply voltage minus 15 volt, that are the clamping voltage for this IC, and divide with 75 microampere, you will find the resistor value. Use that resistor value, so it will give a Micropower startup. When we use this resistor, startup resistor, it will charge this capacitor, VCC capacitor. From VCC capacitor, one diode, that is called bootstrap diode, is used. When it will start charging to this capacitor, at that time VCC pin will start to increase. When it will increase up to its threshold, it will start switching. When it will start switching, these bootstrap voltage will bias up the output MOSFETs that are here at driver stage, so it will start to switch, and we will take high output and low output, LO and HO, high side output signal and low side output signal. Here we have RT and CT. This RT and CT will assign the switching frequency, and there is a shutdown signal. It can be used as a protection. When it will switched on, the ground supply will connect it to CT pin, so the oscillation of this IC will stop. When it will stop, the output will turn off. It will disable the switching. Here is its pin out. Pin number 1 is VCC, pin 2 RT and CT, common. If you want to make a test circuit for this IC, it is very simple. Pin number 1, we will connect to supply voltage. We can say 12 volt VCC, and we will connect a diode 1N4007, and we will connect to pin number 8. Pin number 7, that is high output. Pin number 6, we will connect to ground. Pin number 5, we will take low output. Here is pin number 2, RT. We will connect a resistor between pin 2 and pin number 3, CT. Between CT and pin number 4, that is ground, common, we will connect a capacitor. We will connect a capacitor between 3 and ground. 2 and 3 resistor, 3 and 4 ground. Pin number 6 and pin number 4 are grounded together. This is test circuit. And in this condition, I am using here one LED, 2.2K resistor, one LED, 2.2K resistor. And here, to make it variable, I connected this 4.7 microfarad capacitor. This capacitor is not recommended for normal operation, but for test purpose, because we are not going to drive it for a long time. So 4.7 microfarad capacitor, that is good. If you have oscilloscope, if you have multimeter with frequency option, that time you can use 1 nanofarad capacitor, that will good. And for resistor between pin number 2, this is pin number 2, I use one resistor 50k and potentiometer. This end is open. This is connected to pin number 3. From pin number 3 I am using this capacitor to pin number 4. It is 4.7 microfarad. It is the original condition. It is called RT CT. And using this formula we can calculate the frequency of this IC. But for test purpose I am using this combination. If I will decrease the resistance, the switching frequency will increase. If I will increase the resistance, we can see the switching cycle are now approximately 1.4 Hertz. Let's build the circuit. Here I am using booster module, voltage booster module. I am providing 5 volt and it is providing me 9.4 volt. If you have some 9.4 volt 10 volt power supply, you can use that one. In the project board, in the upper side I have positive and lower side I have ground voltage. I will apply positive voltage to pin number 1. This is pin number 1. I will connect to positive DC rail, and then I will connect a diode between pin 1 and 8. 1 and 8. I will connect ground to pin number 4 and 6. This is pin number 4. This is pin number 4 connected to ground, and pin number 6 connected to ground. And I will connect 2 resistors. This is ground and I will place it here. This is our one resistor, and here I will connect the second resistor, and I will connect cathode of this LED, the short lead, to the resistor, and cathode of this LED to this resistor. The anode, I will connect first anode to pin number 5 and second anode to pin number 7, that is high output. I will place this potentiometer here in the board, and I will connect this resistor to pin number 2, and I will bring this resistor to one side of the potentiometer. The slider arm, the wiper arm, will go to pin number 3. The wiper arm, the center point of this potentiometer, will reach to pin number 3. Between pin number 3 and pin number 4, we will connect this 4.7 microfarad capacitor. This test circuit is ready. If this circuit is working like this, that means this IC is good. And if we see its internal structure, it have very simple combination. This one is 2153S and 2153D. Difference between both models: here is a diode inside, bootstrap diode inside D1, and here is not a diode, so that we need an external diode. In this model we don't need any diode. VCC voltage are here. When VCC voltage are here, internal regulator will regulate and it will start switching. Here is under voltage detector, deadtime control, delay, and here is a logic, RT and CT. This combination will start to oscillate this IC at rated frequency, and it will discharge using this MOSFET. It will discharge this capacitor. When it will reach its at level, this logic will start to switch and this flip-flop will toggle. When Q bar is available at that time, this MOSFET set will drive. When Q is available, this will drive, low side will drive. So this will drive opposite to each other. I hope you enjoyed this video. If it is good, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.